Hello, everyone. Welcome to this live session series on data science with Python. So, this is the fourth live class, and till now, we've learned all the fundamentals of Python, and then we did some basic problem solving. After that, we learned how to do object oriented programming with Python. So, since this is a live series, you can go ahead and put up all of your queries or doubts in the chat section, and I shall go through them. So, also, if you are watching this live, let me know if you guys can hear me and see me properly. Let me also verify it from my end. So, there was a slight issue initially. Let me check if everything is proper now. So, since this is a okay, seems like I can hear myself clearly, and also I can see myself on the YouTube channel. Okay, so everything seems perfect. So now that everything is set up, we can go ahead and start with our live session. So as I was saying, we've covered all of the Python fundamentals. We've also learned how to do object-oriented programming. And this is where, from today's class, we'll dive into data analytics. So the major library which we use for data analytics is something called as Pandas. So we shall be using Pandas library, and with the help of Pandas, we can basically store one-dimensional and two-dimensional data structures. So this is the core library which is used for data manipulation or data analytics or data munging. You can call it whatever you want. And what we'll do is we'll go ahead and start working with this. And since this gives us two types of data structures, one dimensional and two dimensional, let's understand what is this one dimensional data structure. So the one dimensional data structure in Pandas is called as a series object. Now, to create a series object, you'll basically import the Pandas library, and by convention, we give it an alias of PD. So we basically say import pandas as PD, and then through this PD library, so there is a method called as series, and we invoke the series method through the pandas library. So we say PD dot series, and inside this we shall give in a list of values. And this is how we are creating an object, and we are giving this the name of VAL. Now, this is labeled data structure. So when I say a labeled data structure, I basically mean that each of these values over here will have a label or an index. So here, number 10 is present at index 0, number 2, number 20 is present at index 1, 30 is present at index 2, and 40 is present at index number 3. Similarly, over here, we are creating a Boolean type series object. And here you see that true is present at index number 0 and false is present at index number 1. Okay, so we've understood the basic context of what pandas is and what are the types of data structures that we can store with this. So let's go ahead to Google Colab and start coding. I have opened up my Google Colab notebook over here. Now, I need to type in import pandas as PD. So pandas is the library which will be working in today's class, and by default or by convention we'll give this an alias of PD. So you can call it whatever we want. So it's just that since this library was created by convention, we use PD as the alias. So we just say import pandas as PD. And since I want to create a series object, I'll type in pd.series, and here you have to keep in mind that the S over here, the first S which you see, that is capital. So if you've given here a small s, you'll get an error. So you need to give in a capital S. Inside this, we shall pass in a list of values. So let's just say I pass in 10, 20, 30, 40, and 50. And this object I shall store in a new variable called as val. And let me go ahead and print out val over here. And you see that this is of type integer. So all of these values are integers, and we've stored this in value. Now, all of these are also labeled. So by convention or by default, the indexing starts with 0 and goes up till 4. Now, it's not necessary that we have to store only numerical values or integer type values. We can also store Boolean values in this. So let me store a Boolean value. So I'll have true, I shall have false. Let me go ahead and print this out over here. So here you see that true is present at index 0, false is present at index number 1. Now, I'll do something different. I'll pass in a combination of different data types. So I shall have 1, here I'll have A, and I'll pass in true. And let's see what would be the data type. So here you see that the D type is of object. So when you combine all of the different data types, what you have is a series type object. So this is how we can create a series object. Now going ahead, let's see what else is in store. So next up, since I've said that this is a labeled data structure, or you can basically change the label of the indices over here. By default, it was 0, 1, and 2. We can give it whatever we want. So here we are basically saying that this value small a is present at index capital A. This value small b is present at index capital B, and this value small c is present at index capital C. So let's do something similar in Google Colab. Here I'll create a new object. Let's call this as val2. I'll have pd.series and I shall give in some values inside this. I'll maybe call this as value1. I'll have value2 and I'll have value3, and all of these would be present at these indices. So first index would be K1, second index would be K2, and the third index would be K3. Let me go ahead and print this. So as you can see over here, value is present at K1, value 2 is present at K2, and value 3 is present at K3. So this is how we can actually give our own indices while creating the series object. Next up, what we are doing over here is we are creating a series object from a dictionary. So here in this dictionary, the keys are K1 and K2 and the values are true and false. And you shall see over here that by default, the keys are taken as the indices over here and the values are taken as the actual values. So let's go again to Google Colab and create the series object. I'll call this as val3. Again, since I have to create a series object, I'll type pd.series and I'm creating the series object from a dictionary. So my first key value pair, I'll have k1 and the value will be v1. I'll have another key value pair, it would be k2 and v2. Let me print out val3 over here. And as you see, K1 and K2 are the indices and V1 and V2 are the values over here. So this is how we have successfully created a series object from this particular dictionary. Now, since we've also worked with lists and tuples, we basically know how to extract individual elements from a series. If you want to extract individual element from the series object, it sort of goes along the same lines. Let's try this out. I'll create another variable over here. I'll call this as val4 pd.series. Let me pass in some values. I'll have 100, 200, 300, 400, and 500. Let me print this out over here. No attribute series. So as I said, S has to be capital. If you give it small, you will get an error. Let me make it as pd.series with a capital S. And this is our series object. Now, if I would want to extract the first element from this, I can just give val4 and the indexing starts from 0. And this is how I have extracted this. Val4 of 0. Similarly, instead of 0, maybe if I want to extract the last element, so I can type in -1. Key error. Okay, so seems like we can't really use -1 for this. Instead of -1, I shall give in the index, which is 4. And we have extracted the last element. Now, if I were to extract a series of elements, so let's say if I'd want the first three elements over here, so I'll have 0 to 4. And you shall see that I have extracted, so this is actually giving me the first four elements, so 0, 1, 2, and 3. So if I want the first three elements, so I'll have 0, 1, and 2. So in this particular subscription, I shall give in 0 is to 3. So this is how we can basically extract elements from a series object. Now that we have worked with one-dimensional data structure, we'll actually come to the core part of Pandas library, which are data frames. And this is what we normally use for most of our data analytical works. Our data is present in a tabular format, and if I were to perform any sort of analysis on this tabular format, I would need a data frame. And this is where Pandas shows its true powers. So here we are actually creating a data frame from scratch. And again, we are creating this through a dictionary. Here, what I'll do is inside this, I am again passing in a dictionary with key value pairs. The first key is fruit. The values of the fruit are apple and mango. And then the second key is price. And value for price are 10 and 20. Here you shall see that the key values become the column names. Fruit and price, these become the column names, and the values over here, they become the rows. So apple and mango, these become the rows for the column fruit. Similarly, 10 and 20, these become the row values for the column price. Let's go ahead and create this in Google Colab. Let me get a new cell. Since I have to create a data frame, I will type pd dot data frame, and here you need to keep in mind that D and F are capital. So if you do not follow the convention, you'll get an error. So pd dot data frame, and I would want to create a fruit basket. First, I have something called as a fruit, which is the key, and then I'll pass in the values of the fruits. So the first fruit would be apple, and then the second fruit would be mango. Then going ahead, I would have to create another variable called as price. So for this key value pair, I have price. And then going ahead, I would have the values for this. So price, let me just give it as 10 and 20. Let me hit enter and let's see what do we get. So here you shall see that we have successfully created our data frame. Let me store this in something called as df. Let me print out df over here, and this is what we get. Let me check the type of this type of df. And here you shall see that this is of type pandas.core.frame.data frame, which essentially means that this is a data frame. This is a two-dimensional, size mutable, potentially heterogeneous tabular data. And this is the core part for any type of data manipulation work that we do. We have learned how to create a data frame. Next up, we'll work with some inbuilt functions which are present for a data frame. So we have read CSV, through which we can load a CSV file or an Excel file, and we can store it in the form of a data frame. Then, if I want to look at the top 5 rows or the bottom 5 rows, I have something called as the head and tail methods. So the head method helps me to look at the first 5 rows of a data set, and the tail method helps me to look at the bottom 5 rows of a data set, and describe just describes all of the columns which are present in the data set. Now, let's go ahead and work with this. Now, since I'm using Google Colab over here, I can go ahead and upload an Excel file or a CSV file. So here you look at this folder button or files, you click here and you can upload a new file like this. So you have this option of uploading to session storage. And when you click over here, you will get a prompt through which you can upload a file. And that is how I have uploaded this iris.csv file. So this is a very common file which is used for basic data science projects or basic data analytics projects. And this is what I've used over here. Now, since I have the CSV file, the first task would be to load the CSV file. So to load the CSV file, let me just add a comment, load a CSV file through pandas. I'll type in pd.read_csv and I shall give the name as iris.csv, and I'm storing this in a new object and I shall call this as iris. And now I'll use the head method and let's see what is the result. Here, this was the first method which we saw, which was read_csv. So this read_csv is part of our pandas library, and with the help of this, we can load all of your CSV files. And here I'm loading the CSV file, storing this into a variable called as iris, and I'm storing it as a data frame. Now that I've stored it as a data frame, if I want to look at the top 5 rows, so here I can just use in the head method, and here you shall see that I'm being displayed the top 5 rows. And now instead of the top 5 rows, if I wanted to maybe look at the top 10 rows, so I'll just give in the value 10. And here you have the top 10 rows. If I would want to maybe look at the top 3 rows, I'll give in the value 3. And here you see that I have the top 3 rows. Similarly, like the head method, I have something called as the tail method, which would help me to look at the bottom 5 rows. I'll type iris dot tail, and hey, we can here see the bottom 5 rows. By default, we have the 5 rows, and if I want to look at the maybe bottom 10 rows, I'll give in the value 10. Let me hit enter, and here are the bottom 10 rows. Now, similarly, instead of bottom 10, if I were to only have a glance at the bottom 3, I'll give in the value 3, and I have the bottom 3 rows. So the indexing, it ranges from 147 to 149. So in total, there are 150 records in this file. So that is why the indexing ranges from 0 to 149, and the last 3 rows, their indices will be from 147 going till 149. Now, let's also use the describe method, iris dot describe, and let's see what this gives us. So here we get to see that this iris data set or data frame has 4 columns, which are sepal length, sepal width, petal length, and petal width. There is actually one more column, which is species, but this describe method will only show us or describe the numerical columns over here, and it will not by default show you the categorical columns, because all of these which you see, so if you want to look at the mean of something, minimum of something, or the maximum of something, the column has to be numerical in nature, because you can't really find out the mean of a categorical column or the minimum of a categorical column. So here, if we look at the sepal length column, we see that for sepal length of the iris flower, the minimum value would be 4.3 and the maximum sepal length would be around 7.9. Similarly, if I were to look at the petal width, we see that the minimal petal width would be around 0.1 and the maximum petal width would be around 2.5. So these are some of the basic inbuilt methods which are present in the Pandas library. Now, we shall see how to extract individual rows or individual columns from the data frame using lock and ilock. So lock and ilock stand for location and index location. Well, first to work with ilock. So this is my object, which is iris. I'll have iris dot ilock. And if I want to, let me actually show the head first so that it's easier to extract what we want. I have iris dot head, and from this, what I'd want is iris dot ilock. I would want to extract maybe the first 2 columns. So if I want to extract the first 2 columns, I'll have 0 colon 2, which would mean that I'm extracting the first two. So this would actually be the rows. So I'm basically extracting the first 2 rows. So whatever is present on the left side of the comma will indicate the rows, and whatever is present on the right side of the comma will indicate columns. So here with this command, what I'm doing is I'm extracting the first 2 rows and the first 2 columns, and here 2 is exclusive, which would mean I am extracting row number 0, row number 1. Similarly, I am also extracting column number 0 and column number 1. Let me hit enter, and as you see, we have extracted this portion from this entire data frame. So here if you tally this, so you have 5.1, 4.9, and this is 3.5, 3.2. So similarly, maybe if I want to extract all of the columns from this, I can just maybe given 0 to 5 over here. And here you shall see that I have extracted all of the columns. Now, instead of this, maybe if I were to extract only row number 34, so index number 34, so this is how I can extract. So here, these are all of the columns for index number 34 or row number 34. So here at index number 34, you will see that the species is of Setosa, and these are your other numerical values. Similarly, maybe if I want to look at only the species column, So here, so this is 0, 1, 2, 3, and 4. So I shall give in 4. And if I want to look at all the rows, so I'll just give in 0, colon, 0. And this is of type object. So maybe instead of this, I'll maybe give in 149. And here you see that I have extracted all of the rows from this particular column. So this is how we can work with lock and ilock. And let's see if we have anything more. Okay, so we've covered all of the basics in Pandas library. Now what we'll do is we'll try to extract something on the basis of a condition. Let me again show you the head of this. So I have iris.head. So if I were to give you a condition that I would want to extract all of those records where the sepal length is greater than 5. So you see these values over here. So here sepal length is less than 5. So I only want those records where the sepal length is greater than 5. So for this, I'll start off by giving in the condition. So I'll type iris, which is the name of the data frame. And inside the braces, I'll give in the condition, which is sepal len sepal length should be greater than 5. And let me hit enter. So here we actually get that sepal length is not defined. So here I'll pass this in single braces and I'll give in the condition here. Now let's look at this. So let's compare this. So 5.1. So is 5.1 greater than 5? True. Similarly, 4.9. Is 4.9 greater than 5? False. Is 4.7 greater than 5? False. And then you have 4.6. Is 4.6 greater than 5? False. So this condition basically gives us true or false values. So wherever this condition is met or satisfied, we get a true value, and wherever it fails, we get a false value. Okay, now we have this true and false values. Now what I want to do is I want to extract only those records where I have this true label. So I'll just pass this condition inside the iris data frame again. I'll cut this, paste it back inside the iris data frame, and when I hit enter, you shall see that if you look at this particular column, you shall see that all of the values are greater than 5. And initially we had 150 rows, but when we gave in this condition, we have only 118 records. So this would mean that out of the 150 flowers which are present in this data set, 118 of them have sepal length greater than 5. Now similarly, instead of 5, if I were to make it 6, I'll just make the condition a 6 over here. And here you shall see that if you look at the sepal length column again, all of these values are greater than 6. And again, out of the 150 records which we have, 61 of them have their sepal length value to be greater than 6. Similarly, here we see that most of the species either belong to versicolor or virginica. Now, what I can do is I can give in two conditions over here. So the first condition would be this. And then I shall also give in a second condition. I shall say where iris of this would be species, and this species should be equal to Virginica, and let me hit enter. Okay, so I shall again pass these into curly braces over here. I shall also pass these into, these are actually round braces, not curly braces. Let's hit enter. Instead of A and D, I'll use and let's see what happens. So here you shall see that I have successfully extracted only those records where sepal length is greater than 6. So here the first condition is satisfied and the second condition is also satisfied where the species is equal to Virginica. And let's see how many records are present over here. I'll store this in maybe sep over, and let's see what is the length of this. So I'll use the length method, len. Inside this, I'll pass in sepword, And we see that out of 150 records, there are 41 flowers where the sepal length is greater than 6 and the species is equal to Virginica. So, friends, this is how we can perform some very simple and very basic data manipulation or data analysis with the Pandas library. So, thank you very much for joining in. And in the next session, we'll learn how to do data visualization with the Matplotlib library and the Seaborn library. Thank you. And if you like this video, do subscribe to our channel, hit the like button, and share it with your friends. Thank you very much, and I'll meet you in the next.